All right, everybody, I'm ready to get started. Welcome back, everyone. Welcome back to this very late week in the semester. I think it's the 13th week. I'm not exactly sure. It might be 12 or 13, one or the other. Regardless, we are heading to the end. Um, so everybody should be very aware of impending deadlines of stuff that's coming up. That's going to have a big impact on your grade, papers, etc. Hopefully, you're taking care of that stuff. Hopefully you've already taken care of it, but if you haven't, you're taking care of it right now while there's a bit of a lull in the class with respect to exams and whatnot. And of course, then once the paper's done, it's finals time. So uh, a lot of stuff is coming up. It's really the time to really be completely invested in this process. I hope all of you are. And if you're not, it's time to get invested because time is running out. But the light at the end of the tunnel is that it is running out, that we are heading to the break. So you will, again, like I mentioned all the time, get a respite, a chance to kind of unwind and sort of filter out, whatever it is that you felt that may not be that pleasant during this time because you're pushing yourselves, and really kind of exploring the boundaries of what you are capable of, which is not a comfortable process, but it's a good process. It will help you in the future. But definitely you will need some time to kind of unwind after this, and you'll get it. But this is not the time to be unwinding. This is the time to really be focusing on the stuff we're doing. So make sure you're doing that. Make sure you're spending most days focusing on the stuff we're learning. If you are doing bad in this class, you need to actually be learning stuff versus just like trying to kind of casually understand things right before exams, because that's how you wind up getting bad grades on exams. You have to actually learn this stuff in your courses to actually do well on the exams and get good grades. So those of you that have been, just really not doing that well in the first two exams, you really need to pick it up, and you need to be at the top of the curve of the class in the final exam in order to have a fighting chance. So that means that you actually need to be learning things. So make sure you're doing that. I know that there's a lot of people in this class that are actually learning things, and it's very clear based on your performance, and it's excellent because it is going to help you. And some of you are just kind of making it through, as I've already mentioned. And if that's working for you, it's working for you, but it's not going to work for you out there. But hey, it's your choice. But again, the people at the very bottom, you're in a very precarious position, and it's serious. And if you're not doing things right now proactively to try to turn things around, then you need to just come to terms with the fact you're going to have to retake this course. So that's the result of your actions that you've chosen to take thus far. It's not over yet, but it's close. So make sure that you put everything you have into making a strong finish, and ideally things will turn around for you. All right. Beyond that, I have to talk to these people that are like at the bottom, because they're usually the ones coming at me at the end, like, oh, please, no, don't let me fail. Like I'm doing something to them as though you haven't chosen to not be invested in the course the entire semester. Like in the end, like I'm the one responsible for you having to retake the course or whatever. I need to be very clear. Like you are responsible for your actions. Either you are taking the right actions now or you are not taking the right actions now, and that is it. But the majority of you are taking the right actions, and you should be commended for that. Keep taking those actions. It'll pay off for you. You'll get a good grade in the class. You'll be able to reflect, maybe not fondly, but positively on the experience, and move onwards and upwards. All right, so is there anything anyone wants me to address about anything before I move forward with the material today? Yeah. I don't need hard copies of mini papers. Yeah, the whole paper is going to be due on the due date in the syllabus, and that's the day that you should give me the hard copy. But following up to that week, I'll let you know that you can turn it into me earlier. But I know that some of you, like yourself, I know you come to class regularly, so I'm sure you'll be here that day. But for the people that aren't, you will have an opportunity to turn it into me in office hours prior to the deadline, or slip it under my door in my office prior to the deadline. But yeah, I don't need anything now because everything happens in its due time, and I just don't have time to even deal with papers right now. So Yeah, but yeah, again, papers coming up, deadlines, hard copy and digital copy necessary of the final paper to be considered turned in. So make sure you keep that in mind. All right. So again, we are in the last part of the course. We are focusing on the oligopoly market setting, which is the most complicated market setting where firms operate, and it makes their decision making the most complicated. And so the models that help us to explain how they can best make decisions in these circumstances are more complicated than the models we've seen, but do build on the ideas that we have built thus far, because in the end, decision making is, in our approach in economics, based on marginal analysis, and we look at marginal benefit versus marginal cost, and marginal cost is a reflection of the firm's production process, which we studied in chapter 5. So all that stuff still applies, but the difference here is that the firms, when they're making their decisions to produce a certain amount in order to maximize their profits, at the point where the marginal benefit equals their marginal cost, they have to take into account what their rivals are doing as well, because the market is shared by a few large firms. And so what rivals do affect the decision of the firm managers, and thus it's important for firm managers to understand that they have to always be taking into consideration what their rivals may be doing, and that consideration may not be based on a lot of actual tangible information. In the models in this chapter, though, we do assume that everybody has complete knowledge of what everybody else is doing, just to kind of get a baseline understanding of how things should work under these conditions. But in reality, obviously, not everybody has all the information they need, so they have to, try to kind of ballpark it, like just take as much information as one has, and then just kind of try to get into the right range of what they should be doing, given the intuition that you can gain from these models. So there's 4 oligopoly models that we are looking at in this chapter. We've already looked at 1.5 of them, basically 2 of them. But today we'll cover the Cournot model, finish covering it because we started last week. We covered the Sweezy model already. I'll review all that stuff, of course. And then we'll jump into the Stackelberg model, which is the next one. And then there's one more called the Bertrand model, which we'll cover on on Thursday. Oh yeah, and by the way, there's no class a week from today, just as a reminder. And I'll of course email about that and whatnot.
You covered duopolies more, or was it just whatever you went over at the beginning of it?
So all of these are explored through the case of a duopoly, where there's only 2 firms. Yeah. So each of these models, we present them with just only 2 firms operating in the market. Yeah. So they're all duopolies, but a duopoly is an oligopoly with just 2 firms, and the conclusions from these models in the simple case do extend to the more complicated multi-firm cases. Yeah.
When there's a case where there's like 2 really big firms, there's other firms, but they don't really have like a significant impact on the main ones, but it's still considered a duopoly. If like they really don't like affect those 2 main big firms, but they're still in there.
Well, it depends on how many firms are on the market. Like if you're talking about like a couple of large firms, and there's a bunch of small little firms, then that market is going to tend to be like different than like an oligopoly setting. It'll probably be more like a monopolistically competitive setting, because the thing that stops other firms from getting in are barriers to entry in oligopolies. So there's likely to be something stopping other firms from getting in, so that really you couldn't have like a few large firms and a bunch of small ones, because you need to be large to even have a fighting chance, because the cost of the bigger ones are going to be a lot lower than the ones of the smaller ones. So it's not going to be common that you'll find like a couple of large firms and a bunch of small ones kind of competing against them. But if there are small ones that are managing to compete, then they really won't be able to have a big impact on the market, because again, like their slice of the pie will be so small compared to the big ones that it really won't matter. Sure. So again, each of the models that we cover differ in terms of their assumptions that are being made about what the rivals are doing. And so let's again cover the stuff we covered last week on Thursday. Just briefly, in terms of like general conditions for an oligopoly. an oligopoly refers to a situation where there are relatively few large firms in industry. No explicit numbers required, but they usually tend to fall within like 2 to 10 firms. And the higher the number of the firms, the more competitive the market, obviously. And the products that firms can offer may either be the same type of product, an identical homogeneous product, or it may be a differentiated product, a version of a product that's slightly different from what competitors are selling, as in monopolistically competitive markets. And an oligopoly composed of only 2 firms is a duopoly. And the reason why this is the most interesting market setting to study is because firms have to base their decision on what they believe that their rivals are doing, because again, in the end, nobody really knows what their rivals are going to do. And so they need to kind of have an idea of that. But they do need to take that into consideration because they are sharing a downward sloping demand curve, whereas in perfectly competitive markets, everybody faces a perfectly elastic flat demand curve, and everybody can supply as much as they want, and that supply decision depends on their costs. So their marginal cost is compared to the marginal benefit, which is the price that they can sell it at, the good at, and they decide how much to sell. So really, they can sell as much as they want. For a monopolist, they have their own market demand because they're the only firm in the industry, so they face that downward sloping demand curve. And so, if they want to sell more, they have to lower their price. If they want to sell less, they have to raise their price. They raise their price. With these type of markets, it's like it's a monopoly, but it's shared by various firms. And so they share that downward sloping demand curve. And so if a rival decides, oh, I'm going to supply more, then the entire market moves down the demand curve. And so everybody needs to take that into consideration because everybody needs to lower their price if that's happening, or else one firm will wind up with a lower price than the others, and then they'll have a competitive advantage, and then they'll, of course, price them out of the market. So they constantly have to be taken into consideration what their rivals are doing. All right, so we looked at the first model, which was the Sweezy oligopoly. In the Sweezy oligopoly, there are few firms in the market serving many consumers. The firms produced differentiated products, so slightly different versions of what everybody else is selling. Each firm believes that their rivals will cut prices in response to a price reduction, but will not raise their prices in response to a price increase. That means that demand will be more elastic when the prices increase and more inelastic when the price is decreased. And of course, barriers to entry exist, which means firms cannot enter the market easily. It's probably a increasing returns to scale type of situation where you have to operate at a certain portion of the long run average total cost curve. You have to operate like at a point where like average cost is low in order to be able to compete with your competitors, or else your prices are going to be higher than everybody else, and therefore you won't be able to compete. So you have to be that large. In order to be that large, well, you have to invest a lot of financial capital. You have to gain access to financial markets, which requires collateral, etc. So there's a lot of situations that will stop a firm from entering a market where there's increasing returns to scale, which is why only a few firms get to enter and compete in this oligopoly setting. Now, what's defining of this particular market setting, the Sweezy oligopoly, is that the firms think that their rivals will match price reductions and will not match price increases. So again, the demand will tend to be more inelastic if prices are decreased, and more elastic if prices are increased. And so let's say the firm is starting at point B, then if they raise their price, this will be the relevant demand, and so therefore this will be the relevant marginal revenue curve associated with that. Because again, they're just trying to figure out how they can set marginal revenue equal to marginal cost in order to maximize their profits. But the marginal revenue winds up being kind of weird in this situation because demand changes based on whether a price reduction is used or a price increase is used at a particular point. And so this is the marginal revenue curve associated with this segment. And of course, I went through this in very fine detail last time. If you didn't watch the last lecture or weren't in class, I animate this whole thing, and it's very clear how I get to this marginal revenue curve. So if this is not very clear to you now, make sure you go back and figure it out by going through my lecture or reading the book. Anyway, so there's the marginal revenue associated with the demand curve that reflects that they will raise prices and their rivals will not raise prices. And here is the marginal revenue portion that is associated with this demand curve that, again, reflects the fact that rivals will match price reductions. So if you lower your price, your rivals will lower their prices as well, which makes sense. It's a natural sort of response by a competitor. And so the firm then needs to think about this as their marginal revenue curve, corresponding to different elasticities depending on what the firm assumes their rival is going to do. Because of this kind of weird marginal revenue curve, then there is a range over which, if marginal costs were to drop, the firm would not change the amount of output that they sell. Whereas in normal situations, they set their output at the point where marginal revenue equals marginal cost. If marginal cost falls below marginal revenue, then they decide to supply more because, again, marginal cost is less than marginal revenue, so it makes sense for them to sell more because, again, it's profitable for them to do so. And this happens, when their total costs drop for one reason or another. So there's a range over which firms in a Sweezy oligopoly need to be conscious of, that if their costs drop, they should not be increasing the amount of output, or else it's going to hurt their profits. So that's the insight that we gain from this model, purely based on the belief that is embodied in this demand curve, where, again, they believe that their rivals will match price reductions, but not match price increases. So that's the result that we get from this. And of course, this model has been criticized for the notion that it's not really clear on what that price is, where that pivot point happens in the demand curve. And the response is that ultimately these firms need to operate in markets and just kind of figure it out, feel out how the market is working with respect to price increases and price decreases. What are rivals doing? And then you'll ultimately figure out, okay, what that price is that is going to change the nature of my demand, and therefore be able to identify the proper marginal revenue and understand over what range output should not increase when marginal cost decreases. And again, that's a very specific result to this setting, the Sweezy setting. All right, then we moved on to the Cournot oligopoly. So in a Cournot oligopoly, the firms are choosing quantities. That's their main sort of dimension of competition. They're not competing on price. They're competing on how much they're going to supply, because there's only a certain supply that exists, and there's only a certain supply that the market will bear as far as what people will buy. And so we can think of the oil market as one example. There's a few large oil producers that must decide how much oil to pump out of the ground. So they have to decide at the same time how much oil that they should pump out of the ground in order to supply however much they're going to supply over the next coming period. So a Cournot oligopoly, and again, Cournot and Sweezy, these names come from people, so they're not intuitive or in some way linked to the logic of the model. So you just kind of have to memorize them in some way. Cournot, it kind of starts with the same sound as quantity. So Cournot quantity. So that kind of links that, and maybe is a way to remember it, a mnemonic device to remember that. Anyway, so Cournot oligopoly. There's a few large firms in the market serving many consumers. Oligopoly. The firms produce either differentiated or homogeneous products. Each firm believes that their rivals will hold their output constant if it changes its output. So that's the main assumption here, that everybody's making their output decision at the same time. So they have to assume that their rivals' output is constant, because again, there's no reaction because everybody's choosing at the same time. But still, you need to take into consideration that your rivals are choosing output as well at the same time. And so that is what complicates the analysis. Each firm believes that rivals will hold their output constant if it changes its output. I already said that. Barriers to entry exist. Of course, that is what's stopping other firms from entering the Kuno oligopoly, and therefore creating the conditions for only a few large firms operating in the market. So in contrast to the Sweezy model, the Kuno model is relevant for decision making when managers make output decisions. So that's the big difference here between Kuno and Sweezy. All right, so then we started talking about like the way that these firms optimize their output decisions, and they optimize it based on a rule that they are able to derive that's based on the notion of setting marginal revenue equal to marginal cost. But marginal revenue is based not just on their own quantity decision, but on their rivals' quantity decision. So in a duopoly setting where there's only two firms, each firm will have what's called a best response or a reaction function that they will derive from that very standard condition of setting marginal revenue equal to marginal cost. So firm 1 is going to have a reaction function, firm 2 is going to have a reaction function, each one having their output as a function of their rival's output. So we looked at these reaction functions graphically first to kind of understand like what they're telling us and how they can imply to us what it means to be in an equilibrium in this market, like the point where like both firms want to operate, where they are doing the best they possibly can, and therefore the market is at rest. So this is firm 1's reaction function. This is firm 2's reaction function. We have firm 1's quantity, like their control variable, the amount that they can control in the market, on the horizontal axis, and the amount that firm 2 can control, firm 2's control variable on the vertical axis. And so here we have firm 1's reaction function. If firm 2 supplied 0, firm 1 would supply Q1M, which represents the monopoly output in the market. It represents how much they would supply if they were the only firm in the market. And here is the monopoly output for firm 2, again, representing the point on the reaction function that corresponds to firm 2 producing as much as it possibly can given the market conditions, and firm 1 producing nothing. So those are the two reaction functions. And again, they tell the firms how much they can supply or should supply in order to maximize their profits in response to what their rivals would do. So how do we get to an equilibrium? Well, you just assume, let's say, a situation where, let's say firm 1 is the only supplier and then firm 2 enters the market. So this is firm 1's reaction function. This is firm 2's reaction function. This is how much firm 1 is supplying. In response to firm 1 supplying this much, firm 2, based on its reaction function, would supply this much in order to maximize its profits. In response to firm 2 supplying this much, firm 1 would then supply this much in order to maximize its profits in reaction to that. In reaction to firm 1 supplying this much, firm 2 would then supply that much to maximize its profits, and so on and so forth. That process would continue until they would be at the intersection of the two reaction functions, which is the best that each firm can do. They are both maximizing their profits given the fact that they understand that they are sharing the market and they're doing the best they can given that there's this limited competition by very strong competitors. And of course, the process is the same. And on the other side, if firm 2 produces this much, firm 1 will produce that much, firm 2 will produce this much, firm 1 produces that much, and that will get us back to that equilibrium as well. So regardless of whether the market was anywhere other than at these points with both firms producing their what are called the Kuno equilibrium outputs, then the market would move back towards that equilibrium output level because, again, that's the point where the firms are making the most money they possibly can. Again, given that they depend on what their rivals are going to be doing and they share that demand curve. All right, so that was the graph that kind of gave us the intuition about what it means to be in a Kuno equilibrium. Now we went the next step further, of course, to solve for the reaction functions. So we'll do the example again, of course, but just generally, to solve for a reaction function, you have to take, first of all, you have to acknowledge that if it's a duopoly, you have to acknowledge that there are two firms choosing output levels. And so we have to separate the quantities in our inverse demand function into the quantity variable of one firm and the quantity variable of the second firm, the amount that they will each choose to supply, which added together will be the amount that will be supplied in the market. So then once you divide up the market into the two firms' control variables, and then you just distribute that out mathematically, like multiply negative b times each variable there. Then you take the perspective of a firm. So let's say you're going to take the perspective of firm 1. Well, taking the perspective of firm 1 means that you are taking firm 2's output as constant. So therefore, you need to take the firm 2's control variable and put it into your constant. So then you have P equals A minus BQ2 is the constant, and then you have minus BQ1 is the slope of the inverse demand for firm 1. So to get to the marginal revenue of firm 1, then you just double the slope on that variable, which we did here. So again, they've taken the firm 2's output as constant, A minus BQ2, that's their constant. They just assume that firm 2's output is constant, and then they have negative BQ1 as the residual demand, and then they double that to get to their marginal revenue. So this is firm 1's marginal revenue. You do the same thing to get to firm 2's marginal revenue, which will be symmetric. You just switch the subscripts there. And then in order to solve for the Kuhn equilibriums, you have to set each of their marginal revenues equal to their marginal costs. Here we assume their costs were just equal to C1, Q1. So marginal cost for each one was equal to C1 and C2 for firm 1 and firm 2 respectively. So setting either of them, so setting firm 1's marginal revenue equal to marginal cost allows us to then derive a relationship between firm 1's output, how much it wants to supply Q1, as a function of Q2. And that just involves doing some algebra, which I did over here, which then got me to firm 1's reaction function, which looked like this. Now, you don't need to memorize this very general stuff. It's just, again, meant to kind of highlight the mechanics of solving for these things. But the practical problem that we do next is, the one that really kind of solidifies how this works. But this is just like sort of the general approach to getting to the reaction function. And then you do the same thing for firm 2, set its marginal revenue equal to marginal cost, and then you can solve for firm 2's reaction function. So let's once again do that demonstration problem, 9.4. We'll suppose the inverse demand function for two Cournot duopolists is given by this inverse demand function. Here we've already separated the quantities into two firms' control variables. Again, like if this was a market with 3 firms or 4 firms, and there would be a quantity variable for each one, and each firm would have to take into consideration what all the other firms are doing. We assume that their costs are 0 just to keep it simple in this problem. So the first question is, what is each firm's marginal revenue? So again, what you want to do, well, let's just go through the questions first. Second, what are the reaction functions for the two firms? Third, what is the Cournot equilibrium outputs? And 4, what is the equilibrium price? All right, so to get the marginal revenue, you have to take the perspective of a firm. So step 1 is to take the perspective of a firm. We'll pick firm 1, let's say, and we'll take the other firm's output as given. So again, assuming that the other firm's output is given, it means that you put their output in your constant. So this is firm 1's perspective on the market by assuming that firm 2's output is constant. It's what we call the residual demand for firm 1. And now we just do what we normally do to get a marginal revenue, because essentially at this point, if there's 2 firms and the one firm that's in control is assuming that the rival's output is constant, then that means that whatever's left for them to supply in the market is all that is left to supply in the market. So they are essentially a monopolist now. And so they maximize profits as any monopolist would by setting their marginal revenue equal to marginal cost. So again, just to get the marginal revenue equation from this equation, you double the slope and absolute value there. So that's what we did there. Again, they've taken firm 2's output is constant, so that stays in the constant, and we double the slope coefficient on Q1 to get firm 1's marginal revenue equation. And then we set And then we can do the same thing for the second firm. Everything's the same. Both of their they both share the same demand, obviously, so they're going to get the same marginal revenue. We're just going to switch the subscripts on the quantity variables. What are the reaction functions for the two firms? Well, the reaction function, again, is solved for by setting marginal revenue equal to marginal cost, and then solving for the firms that you've taken the perspective of their quantity variable as a function of their rival's quantity variable. So we're going to set marginal revenue equal to marginal cost and solve for one firm's output in terms of the other firms. So here's firm one's marginal revenue. Remember, the costs are 0, so marginal cost is 0. So now it's just algebra. You set that equal to 0, and you solve for Q1 in terms of Q2. So you can subtract this term from both sides, and then divide both sides by -2. And that's going to get us to Q1 equals -10 divided by -2 is 5, and then you've got positive Q2 divided by -2, so that's 1 minus 1/2 Q2, so that's firm 1's reaction function. This is, again, the relationship that tells firm 1 how it should set its quantity in order to maximize its profits in response to what its rival's doing. And then to get firm 2's reaction function, we would do the exact same thing, just set its marginal revenue equal to marginal cost. But in this case, everything's the same. We've assumed everyone's marginal costs are the same. So we're going to get to the same reaction function. So we get to the same reaction function, but obviously in this case, it's firm 2's output is a function of firm 1's output. So Q2 is a function of Q1. So you just basically switch the subscripts there. So again, these are the equations for those lines that we saw on the graph earlier. And so to get the Coulomb equilibrium, we have to figure out where these two reaction functions intersect. So to do that, we just have to solve for these two quantities using these two equations, which is just algebra. It's just a system of equations. So to solve for the Coulomb equilibrium outputs, plug one reaction function into the other reaction function. So let's say we take firm 1's reaction function and plug in firm 2's reaction function for Q2. So plugging in Q2 equals 5 minus 1/2 Q1 into Q2 gets us this expression here. And now it's just algebra once again. So Q1 equals 5 minus 1/2 5, which equals 5 halves. Plus 1/4 Q1. Okay, so then we need to combine our Q1, so that's going to be moved over to the left-hand side, and then 5 minus 5 halves leaves us with 5 halves. So subtracting 1/4 Q1 from Q1 gets us 3/4 Q1. And now we want to, of course, solve for Q1, so we just multiply the whole thing by the reciprocal of 4/3 to get rid of 4/3 on the left side. And that gets us to firm 1's Coulomb equilibrium output to be 10/3. And then to solve for firm 2's output, we plug in Q1 into firm 2's reaction function. So this is how much firm 1's going to choose. So to figure out what firm 2 is going to choose, they plug in what firm 1 is going to supply, and then they figure out how much they're going to supply optimally in response to that. And because, again, the reaction functions are the same, because marginal costs are the same, the Coulomb quantities will wind up being the same as well. So plugging in 10/3 into the firm 2's reaction function, 5 minus 1/2 10/3, that's equal to 10/6, or 5/3 if you reduce it. Then you got 5 minus 5/3 equals 10/3. Because 5 equals, again, 15/3. So 15/3 minus 5/3 equals 10/3. Anyway, you get to firm 2's Coulomb equilibrium output to, as I said, be exactly like firm 1's output, because the reaction functions are the same, because each one had the same marginal costs. And again, those are the quantities that occurred at the point where the two reaction functions intersected on the graphical representation of these relationships. Any questions on this? All right, and then to solve for equilibrium price, you just have to plug in each of the firm's Kuno outputs, what they're going to supply into the inverse demand function, and then we can figure out what the market price should be. So that's exactly, so you see now why each firm needs to take into consideration what their rivals are doing, because if they only use their own output, then they're going to wind up with a higher price than they should be charging, which means that, again, they won't have a competitive advantage and they could wind up losing. So P minus 10 thirds minus 10 thirds, plugging in 10 thirds into our inverse demand function, gets us to a price of $3.33, which is what this market should be charging for everybody to maximize profits, given that there's interdependence in decision making. All right, so in a Kuno oligopoly, industry output is lower than the socially efficient level. So you're going to get, once again, that situation where the firms are going to have the power to, again, charge price above their marginal cost. So you're going to have some deadweight loss. The amount by which price exceeds marginal cost depends on the number of firms in the industry as well as the degree of product differentiation. So if there's less product differentiation, that means everybody's selling closer to the same thing, then the amount, the markup, the difference between the price and marginal cost will be less. If there are more firms in the industry, again, you're going to have a more competitive outcome, so the markup will be less as well. When the number of firms is arbitrarily large, when you have a large number of firms in these oligopolies, then the equilibrium price in a homogeneous product Kuno market is going to be arbitrarily close to marginal cost. So you're going to start getting very close to that result that industries experience in perfect competition, where price equals marginal cost and there's no markup at all, and in the long run there's zero economic profit. So again, barriers to entry are very important for these firms to be able to make the kind of profits that they want to make, because if there aren't barriers to entry, firms will enter. The more firms enter, the more they have to share the market. Ultimately, the more the market starts to approach the perfectly competitive outcome, which is, again, the most efficient outcome, which is the best for consumers, but not the best for profits of individual firms. But better for society because there's no deadweight loss. All right, so let's consider what happens when marginal costs change. So again, with the Sweezy oligopoly, if marginal costs change, there's going to be a range over which nothing should be done by managers. That's not the case in a Kuno oligopoly. So in a Kuno oligopoly, the effect of a change in marginal cost is very different from that of a Sweezy oligopoly. Suppose that the firms initially are, let's say, at this equilibrium. So here's firm 1's reaction function. Here's firm 2's reaction function. There are their Kuno equilibrium outputs, Q1 star and Q2 star. Suppose further that firm 2's marginal cost declines. So firm 2's marginal cost declines. That means when they set their marginal cost equal to their marginal revenue to derive their reaction function, that's going to result in a different reaction function. So essentially, it's going to shift their reaction function. And if their marginal cost is going to decrease, then it's going to result in a situation where they're the ones that are going to want to be able to supply more. So this means that for firm 2, marginal revenue will exceed the lower marginal cost, and it's optimal to produce more output for any given level of Q1. So that means that the reaction function shifts. In this case, it will shift out, and it will get us to this new equilibrium point for this Kuno duopoly, which again corresponds to firm 1 responding optimally to the changes and supplying less, and firm 2 supplying more. Again, completely in response to the fact that firm 2's costs have gone down. So if they were initially at this equilibrium and firm 1 was supplying Q1 star, and then firm 2's reaction function went up, that means firm 2 would supply this much in order to optimize its profits. Firm 1 would respond by supplying this much, firm 2 would respond by supplying this much, and so on and so forth until we get to that equilibrium. So the market, it would move along that sort of dynamic path that would get them to that new Kuno equilibrium, given, again, the fact that marginal cost has fallen for the second firm. So the reduction in firm 2's marginal cost leads to an increase in firm 2's output, from Q2 star to Q2 double star, and a decline in firm 1's output from Q1 star to Q1 double star. Firm 2 enjoys a larger market share due to its improved cost situation. All right, now let's look at profits. So one way we can throw profits into the graphical representation of the Cournot equilibrium is by using what's called isoprofit curves. Isoprofit curves are used to graphically determine the firm's profits. So they're the basic tool used to summarize the profits of a firm in Cournot oligopoly, which defines a combination of outputs of all firms that yield a given firm the same level of profits. So here's 3 different isoprofit curves for firm 1. The figure represents the reaction function for firm 1 and 3 isoprofit curves. So this isoprofit curve represents, again, combinations of output of both firms that will yield the same amount of profit. So if firm 1 supplies this much and firm 2 supplies this much, then firm 1 will make this much profit. If firm 1 supplies this much and firm 2 supplies this much, then again, firm 1 makes the same kind of amount of profit. And then the point at which both firms are supplying as much as possible to maximize their profits, given that they have to react optimally to each other, happens at the point where the isoprofit curve cuts through the reaction function. So 4 aspects of isoprofit curves are important to understand. Every point on an isoprofit curve yields firm 1 the same level of profits, as I've already mentioned. Isoprofit curves that lie closer to firm 1's monopoly output are associated with higher profits for that firm because, again, monopolies make the most profits. So if a firm is able to be a monopolist, they're going to make the most amount of profit. So as the isoprofit curves get closer to that output level, then they are going to represent higher levels of profit. So this closest one represents the highest level of profit for this firm out of these 3. The isoprofit curves for firm 1 reach their peak where they intersect firm 1's reaction function, as we already saw earlier, as I already mentioned. That's where they reach their peak, when they cross the reaction function. And the isoprofit curves do not intersect one another, because then they wouldn't make sense, because then you would have the same profit in 2 different isoprofit curves. So that's not something that could happen. So suppose firm 2 decided to provide Q2 star units of output in this market. Firm 1 believes that firm 2 will produce this output regardless of what firm 1 does. It takes its rival's output as constant. So it chooses an output level to maximize its profit when firm 2 produces Q2 star. It could produce this amount, Q1A, and it would then wind up making pi 1A amount in profits. But it could also expand its output to Q1B, in which case it would be making more profits because it would be on a higher isoprofit curve, higher relative to the monopoly output. Profits can be further increased by increasing their output to the point where they are producing Q1C. And so that obviously is the point that corresponds to the reaction function. So that is going to be representative of the best that the firm can do in response to firm 2 producing Q2 star. And it also corresponds to the point on the highest isoprofit curve. If the firm were to go even further than that to point D, then again, you would see that they would wind up making lower profits. They'd be on the lower isoprofit curve. So it's not profitable for firm 1 to increase output beyond that Q1C, given that firm 2 produces Q2 star. The profit maximizing output for firm 1 is Q1C, the amount corresponding to the point on its reaction function whenever firm 2 produces Q2 star. So to maximize profits, firm 1 pushes its isoprofit curve as far down as possible, as close as possible to the monopoly point, until it's just tangent, just touching the the given output of firm 2. So that's firm 2's output. The highest amount of profit it can make is the one that corresponds to the point that just touches the highest ISO profit curve, and of course that corresponds to the point on the best response function, the reaction function. Yeah.
Those three curves, I1A, I1A, I1C, those are the isotopic curves?
Mm-hmm.
Okay, so can you explain again why I1C would yield higher profit? Just like why that it's like lower down on the
Because they correspond to quantities that are closer to the firm's monopoly level. And so the monopoly output is what represents the most amount of profit a firm can make. So as long as they're getting as close as possible to that, their profits will be increasing. And so these ISO profit curves, again, as they get closer to the monopoly level, represent higher levels of profit. All right, so ISO profit curves for firm 2 are the mirror image of those of firm 1. So here they are again and again as we get closer to the monopoly output for firm 2, the ISO profit curves represent higher levels of profits as well. So it works exactly the same way in the opposite direction. All right, so we can use ISO profit curves to illustrate the profits of each firm in a Kuhn equilibrium. So this is the Kuhn equilibrium again. Here's firm 1's reaction function. Here's firm 2's reaction function. There is the point where they intersect. Those are their Kuhn equilibrium outputs. And again, they represent the best that the firms can do given the nature of the competition. And so they both wind up operating on these ISO profit curves, firm 1's ISO profit curves, firm 2's ISO profit curve. All right, so that's like the baseline case. All right, so now we're going to use this framework to get our first understanding of like another complexity that arises in these markets. So the firms want to engage in collusion. They want to work together because if they work together, then they share the market like a monopolist. They make the most amount of money like a monopolist does. They can just split that and they're happy. In order to do that, they have to be able to limit the amount of output that can be supplied in the market. Because again, they want to be able to get as much profit as possible. Monopolists wind up limiting the amount of output as much as possible in a market in order to be able to do that. And so that's what the firms want to do. Unfortunately, they cannot do that because there are laws against firms working together to rig markets. They're very clearly established here and other Western nations. But you know, the laws do get kind of murky when you think about international situations. That's why you can have like, you know, like the different countries in the Middle East sort of controlling the amount of oil together, and basically them getting together and deciding we're going to supply this amount in order to reach this price. Like they're basically doing what our laws are stopping companies from doing, but they're able to do it because it's outside of the jurisdiction of you know, domestic laws of individual countries. When firms are able to do that, collude together to rig markets, they're called a cartel. So the OPEC, the Organization of Petroleum Exporting Countries, is a cartel that basically controls the oil supply that comes out of the Middle East, and they're able to kind of rig the market to set the prices that they want to set. But again, that's something that's not possible to do in the U.S., not possible to do in European countries and other Western developed nations, and even some non-developed nations. Even though those countries tend to have obviously less sort of rigid legal structures because there's more corruption there, and their legal structures aren't as solid as they are, or relatively solid as they are here. So these firms want to do it. They can't do it, but sometimes they try to do it. Sometimes they'll still try to get together and do it, but they can get caught, and they have to face the extent of the law. And there's been situations where board meetings have been bugged, and federal agents run in and they put everybody in prison, and there are repercussions. But it's rare because again, that has to be somehow transparent to these agencies, and that obviously can get muddy as well. Nonetheless, there is an incentive for them to collude, and there's a possibility they can collude, but if they do, it's illegal. And so if they do somehow manage to get together and make these arrangements, there's no legally binding way to enforce the arrangements. And so they could decide, yeah, let's all supply only this much and lower price and raise prices and make all this money. But there's no way to enforce that. So either side of those arrangements has an incentive to cheat and supply more than they say they're going to supply, and supply at a lower price, which then would make them more competitive than their rival, which means that they win in the market. So that's part of the complexity of this whole thing. Like, the firms have an incentive to work together. They can't, and so they try to, but they have no way of enforcing them. And because there's no way to enforce them, they have an incentive to cheat on the agreements, which even complicates the situation even more. So we can look at why that is using our framework here of ISO profit curves and the reaction functions. So whenever a market is dominated by only a few firms, firms can benefit at the expense of consumers by agreeing to restrict output, or equivalently to charge higher prices. Yeah, so in the next chapter, we'll devote considerable attention to collusion. The next chapter is based on learning the approach and applying the approach of what's called game theory, where again, you have situations where there's interdependence in decision making, where you have to take into consideration what your rivals are going to do. And game theory is basically an approach to handle those kind of situations. So we'll be able to kind of examine this scenario again and kind of gain some insights from that analysis in the next chapter. But here we can start to kind of highlight the nature of these issues with this framework. All right, so it's useful to use the model of Kuno oligopoly to show why such an incentive exists to collude. So this shaded area here, the area that basically exists within this sort of boundary created by the ISO profit curves in the Kuno equilibrium, that shaded area contains output levels for which the two firms could yield higher profits than they would in the Kuno equilibrium. So if both of them were to maybe supply here, where firm 1 supplied this, firm 2 supplied this much, and firm 1 supplied this much, then they would be on higher ISO profit curves relative to their monopoly levels, and so they would be making higher profits. So that just highlights the fact that they can do that, and the fact that there's an incentive to do that. So firm 1's profits would be highest, obviously, at Q1M, where it's a monopolist. And firm 2's profits obviously would be highest, where it is a monopolist. The firms would end up somewhere on the line connecting those 2 points if each agreed to produce an output that in total equaled the monopoly output. So points that connect these 2 lines correspond to overall monopoly outputs for the market. If there was only one firm in the market, the one firm would either supply this amount or some amount along these 2 lines. That represents a combination of what the 2 firms would supply in this scenario. So any point on these 2 lines would, again, yield higher profits overall in the market. And then in this point, both firms would be making more profits than they would be in the Kuno equilibrium. Suppose the firms agreed to collude. So they got behind closed doors. The feds didn't bug them. They were able to get away with rigging the market. They decided, well, I'm firm 1, I'm going to supply this much, and you're firm 2, you're going to supply this much. So we can already see that those levels are definitely less than the amount that would have been produced in the Kuno equilibrium. And both firms wind up making higher profits. But again, that arrangement is illegal. Like, they cannot sustain that arrangement anyway. If anyone cheats, there's no way to legally enforce the arrangement. There's no way to go to court and say, hey, they broke the arrangement. Oh, the illegal arrangement? You're both off to prison. Like, it's like you just can't do it. So firm 1, so we can see now that firm 1 has an incentive to cheat. So they both decide that they want to supply here. But if firm 1 were to supply this amount here, which corresponds to this higher, even higher ISO profit curve, then it would wind up making higher profits. So a firm can gain by inducing other firms to restrict their output and then expand its own output to earn higher profits at the expense of its collusion partners. It's often difficult for them to reach collusive agreements in the first place because firms know that this incentive exists. The problem is amplified by the fact that firm 2 at that output level, so if firm 1 were to produce this much output, then firm 2 earns less here than it would have earned at the Kuhn equilibrium. Then firm 2 would wind up operating on this ISO profit curve, which is going to be further away from their ISO profit curve corresponding to the Cournot equilibrium, the pi 2 Cournot. So again, firm 1 has an incentive to cheat. If they do cheat, firm 2 would wind up making even less profits than they would have made had everybody just like gone along with like the natural outcome of this situation without trying to break any laws or trying to rig the market to gain more profits. And so that's really the big sort of, besides the fact that there's interdependence in decision making, that's the other big sort of challenge to these firms, is that there again is an incentive to work together, there's an incentive to cheat, and there's no way to enforce arrangements, and that just complicates the situation because obviously in the end firms want to maximize their profits, which is how they maximize the value of their firms. All right, now let's change the situation slightly by making an assumption that the situation is very similar to the one we just looked at, the Cournot oligopoly, but the only difference is that one firm gets to make their output decision first, and then everybody has to respond to that. So instead of everybody choosing their output levels at the same time, one firm has an advantage. They get to supply the oil first, and then everybody else, based on what the first firm does, responds in the best way they possibly can. So up until this point, we've analyzed oligopoly situations that are symmetric, in that firm 2 is the mirror image of firm 1, right? There's symmetry in the market. Everybody kind of does similar things given similar conditions. In a Stackelberg oligopoly, firms differ with respect to when they make decisions. Specifically, one firm, the leader, is assumed to make an output decision before the other firms. Given knowledge of the leader's output, all other firms, the followers, take as given the leader's output and choose outputs that maximize profit. So they react in a way that, in the same way they would if they were in a Cournot setting. They would basically develop a reaction function to what the leader has done and then supply optimally based on that rule. So they do exactly what we just did in the last section in response to what the leader does. So in a Stackelberg oligopoly, each follower behaves just like a Cournot oligopolist. The leader does not take the follower's output as given, though. The leader does not assume that the output of the followers is just given, because again, it's not given. For the leader, they can do whatever they want first, and then everybody reacts to that. So it's not given. It's going to be completely a reaction to what the leader does. And so then the leader needs to take that into consideration. The leader needs to take into consideration that it knows that the rivals are going to respond to it in a Cournot reaction fashion in order to maximize its profits. Because even though it can do whatever it wants initially, it does need to take into account that it shares the market with these other firms. Remember, the leader's not necessarily bigger, it just has that first move advantage. And so in the end, they're still sharing a market, they're still sharing a downward sloping demand curve, so their decisions are still affecting each other, that rivals do. So the leader chooses an output that maximizes profits given that each follower will react to this output decision according to a Cournot reaction function. All right, so Cournot is characterized as a Stackelberg oligopoly if there are a few firms serving many consumers, so that's an oligopoly. The firms produce either differentiated or homogeneous products. A single firm, the leader, chooses output before all other firms choose their outputs. All other followers, all other firms, the followers, take as given the output of the leader and choose outputs that maximize profits given the leader's output. And of course, barriers to entry exist. Firms are being kept out of these markets in some way. To illustrate how a Stackelberg oligopoly works, let's consider a situation where there's only two firms. Firm 1 is the leader and thus has the first mover advantage. Firm 2 is the follower and maximizes profits given the output produced by the leader. The follower's profit maximizing level of output is determined by its reaction function. All right, so in the diagram here, we've got the follower's reaction function, R2. The leader knows the follower is going to react according to R2 and must choose a level of output that will maximize its profit. So even though, again, it is the first mover, it is the leader, it knows the follower is going to do something in response to what it does, which is going to affect its profits. So it needs to take into consideration that that's going to happen and how that's going to happen, which is based on firm 2's reaction function. So the leader chooses the point on the follower's reaction function curve that corresponds to its highest level of profits. So it chooses this output level that corresponds to the highest ISO profit curve possible that's just going to be touching the follower's reaction function. The follower observes the choice that firm 1 makes, right? Firm 1 decides we're going to supply this amount of oil. Firm 2 observes that and responds optimally based on its reaction function. So if firm 1 decides to supply Q1S, then firm 2 will respond to that by supplying Q2S. The leader's profits are higher than they would be in a Cournot equilibrium, and the follower's profits are lower than in a Cournot equilibrium at this point. So here's the Cournot equilibrium. Here's the ISO profit curves corresponding to firm 1 and firm 2 in, again, a Cournot setting, which is the one we just considered. But here, because the leader has the first mover advantage, they get to operate on this ISO profit curve, making significantly more profit than they were making before. But firm 2 has to react to that and making significantly less profit than they would have if the firm did not have that first mover advantage. Yeah. No. So they share the demand curve, right? So if they're moving along the demand curve and they're increasing output, they have to be lowering the price. And that's ultimately, the last part of these problems is to solve for the price, right? So like in the end, once everybody's chosen their quantities, then you have to figure out, okay, well, what is the amount that people are willing to pay for that? And so, yeah, prices are changing, of course, based on what these firms are doing. Well, yeah, exactly, because well, yeah, it's outside of the demand curve, right? So the demand curve is like what constrains how much they can sell on the market because it represents what people are willing to buy, right? So that's ultimately the most important limitation that they face, and that's why it becomes complicated because they're all together moving along that curve as they're making output decisions. And that's what all of this is doing, is kind of helping them to figure out how to best get to the best point on that demand curve to charge the best price to get the most profits, given that people are reacting to what everybody's doing, in these ways. So. It's just based on market conditions, yeah. Yeah, the only thing that the law stops them from doing is getting together and deciding together what to do. They cannot do that because that is illegal. Collusion. All right, yeah. So we see that in a Stackelberg setting, simply because one firm gets to make their output decision first, that it completely changes the outcome for the market. That one leader winds up making more profit than the Cournot oligopolist did, and the followers wind up making less profit than they would have in a Kuno setting. So by getting to move first, the leader earns higher profits than it would otherwise be the case. All right, now let's look at your favorite part, the algebra. The algebraic solution for a Stackelberg oligopoly can be obtained provided firms have information about market demand and cost. In particular, recall that the follower's decision is going to be identical to that in a Kuno model. So the follower will have a Kuno reaction function. So the follower will solve for the reaction function the same way that we solve for the Kuno reaction function in the last section. So for example, when you have homogeneous products, linear demand and constant marginal cost, the output of the follower is going to be given by just a very standard reaction function that, again, is just the general form that you can solve for given what we looked at in that example. Make sure you know how to do that. Don't just try to memorize equations, because memorizing equations is silly. You're just memorizing random things that mean nothing, because, again, the equations change depending on the circumstances. So you need to be able to derive the equation, which just requires you kind of listening to 10 minutes of me talking on the recording and just kind of figuring it out. It's not that hard. All right. The leader in the Stackelberg oligopoly takes into account the reaction function of firm 2 when it selects its output. So again, firm 1 is going to supply a certain amount, and it's going to be the leader. It's going to get to make the first move, but it knows that the follower will react in a Kuno way based on the reaction function that it solves for. So it needs to take that into account. So we can highlight how all of this works via a demonstration problem. Suppose the inverse demand function for two firms in a homogeneous product Stackelberg oligopoly is given by this inverse demand function. The cost functions for the two firms are identical. Marginal cost is not equal to 0 this time. It's equal to 2, the derivative of our total cost function. So we just keep it simple here. There's no fixed costs in these examples, just to kind of keep the stuff simple, because this is not about cost. We're done talking about specifically cost. We're talking about interdependence in decision making for firms in oligopoly settings. All right, so firm 1 is the leader and firm 2 is the follower. So we're going to solve for firm 2's reaction function first, because again, firm 1 needs to take into consideration what firm 2 is going to do in response to it when it makes its first move. So in order to do that, we need firm 2's reaction function. Then we can solve for firm 1's output. Then we can solve for firm 2's output. Once we know what firm 1 is going to supply, we can plug that into firm 2's reaction function to figure out how much firm 2 is going to supply. And then we can solve for the market price by plugging both of their outputs into our inverse demand function. All right, so what is firm 2's reaction function? Well, it's solved for as you normally would. You, again, take the perspective of firm 2, and then, so that's 50 minus Q2. So 50 minus Q1, so we're doing firm 2. So firm 2 takes firm 1's output as constant, so 50 minus Q1 is the constant. And then you have minus Q2 is the residual demand. So you just double the slope on that. So that's what we did to get to firm 2's marginal revenue. 50 minus Q1 is a constant, minus 2 times its slope, which is 2 times Q2 to get to firm 2's marginal revenue function. We're going to set that equal to firm 2's marginal cost, which is equal to the derivative of the total cost function, which is equal to 2. And now we're going to solve for firm 2's output as a function of firm 1's output. Subtract this from both sides, divide both sides by negative 2. That gets us to 24 minus 1/2 Q1. This is firm 2's reaction function. Firm 2 is a Cournot reaction, reactionary oligopolist, again, reacting to the first move made by the leader in this Stackelberg setting. Yeah. Yeah. Oh, no, because it's firm 2's marginal cost. We set firm 2's marginal revenue equal to firm 2's marginal cost, which is equal to 2. All right, so that's firm 2's reaction function. What is firm 1's output? Well, it needs to take into consideration, like I said, the fact that firm 2 is going to react in a Cournot fashion. So basically, it's going to take firm 2's reaction function and plug it into the demand function for Q2. And that's its way of sort of incorporating that condition into its perspective on demand. The fact that in order for it to maximize profits, it needs to take into consideration how its rival is going to respond. It does that by incorporating firm 2's reaction function into the demand function. So here's the inverse demand function, plugging in Q2 equals 24 minus 1 half Q1 into Q2. Gets us this expression here, 50 minus Q1 plus 24 minus 1 half Q1. And now we can just simplify, the leader can just simplify this to get it to the demand function it needs to actually deal with in order to figure out how much it should provide in the market. So now having incorporated what its rival is going to do, now it can just approach the market as a monopolist. It has the first mover advantage. So here's 50 minus Q1 minus 24 plus 0.5 Q1. So that's 0.5 Q1. So that's negative 0.5 Q1, and that's negative 24 from 50, which gets us 26 there. Anyway, this is the perspective on the demand in the market by the leader, and now it just has to set its marginal revenue equal to marginal cost. So it doubles the slope in absolute value. 26 minus Q1, set it equal to its marginal cost, which is equal to 2. Solving for its output now, just simply Q1 equals 24 is going to be the leader's output decision. It's going to be 24 units. And now firm 2 can respond optimally to that by plugging in 24 into its reaction function and getting to, so this is 24 minus 1 half 24. 24, so the optimal output for firm 2 is equal to 12. And then now we have both the leader and the follower's outputs. Plugging both of them into the inverse demand function will get us to the market price, which is equal to $14. I'll go over this example again at the beginning of Thursday. So if you have a question?
I just want to see the note that I didn't get down all of how you got from 26 minus 2.
I'll cover it again on the beginning of class on Thursday. Anyway, that's how you solve for the Stackelberg equilibrium, and we are done for the day. Have a good couple of days. I'll see you guys on Thursday.